In a world where military aviation constantly pushes the boundaries of speed, stealth, and technology, one aircraft is set to redefine aerial superiority: the SR-72 Darkstar. Shrouded in secrecy, this powerful aircraft has fascinated aviation enthusiasts, defense analysts, and tech visionaries alike. Often compared to its legendary predecessor, the SR-71 Blackbird, the Darkstar has been the subject of speculation for years. Now, in 2025, after extensive delays and numerous rumors, the U.S. Air Force has officially confirmed its readiness for action. But what does this mean for global defense? And how does this new aircraft measure up against past aviation legends? The birth of a legend, the SR-71 Blackbird. The story of the SR-72 Darkstar cannot be told without delving into the rich history of the SR-71 Blackbird, a Cold War-era reconnaissance plane that revolutionized aerial surveillance. The need for such an aircraft arose in the 1960s during a period of heightened tensions between the United States and the Soviet Union. In 1960, American pilot Harry Powers was shot down over Soviet airspace while flying a U-2 reconnaissance plane, exposing vulnerabilities in U.S. aerial intelligence operations. This incident made it clear that a new, more advanced aircraft was required, one that could fly faster and higher while remaining undetectable to enemy defenses. The Blackbird was designed to exceed these requirements, reaching unparalleled speeds and altitudes, ensuring it remained beyond the reach of enemy interception. Lockheed Skunk Works and the birth of the A-12. In response, the Central Intelligence Agency approached Lockheed Martin's top-secret Skunk Works division in 1957, tasking them with designing a revolutionary reconnaissance aircraft. This led to the creation of the A-12, a prototype that would eventually evolve into the SR-71 Blackbird. Under the leadership of the brilliant Kelly Johnson, the A-12 incorporated advanced stealth technology and an unprecedented speed capability, setting the stage for what would become one of the most significant breakthroughs in military aviation. The aircraft's design utilized cutting-edge materials and construction techniques to minimize radar detectability and maximize endurance at high speeds, ensuring successful intelligence missions behind enemy lines. The SR-71 Blackbird, developed as a successor to the A-12, officially entered service in 1966 and became the world's fastest operational aircraft, reaching speeds of Mach 3.2 over 2,000 miles per hour, and flying at altitudes of 85,000 feet, essentially at the edge of space. The Blackbird's titanium construction allowed it to withstand the extreme heat generated by friction at such high speeds. This iconic aircraft was used extensively for intelligence gathering, remaining virtually untouchable even when targeted by enemy missiles. Over its operational lifespan, the SR-71 dodged over 4,000 missiles, yet not a single one ever managed to hit it. This level of survivability was unmatched and cemented its reputation as the ultimate spy plane. The need for a successor. Enter the SR-72 Darkstar. Despite its unparalleled capabilities, the SR-71 was retired in the late 1990s due to its high operational costs and the emergence of satellite reconnaissance technologies. However, the need for a high-speed, survivable reconnaissance aircraft never truly disappeared. With the rapid advancements in hypersonic weapons by rival nations like Russia and China, the U.S. realized that it needed a successor to the Blackbird, an aircraft capable of not only surveillance, but also delivering hypersonic payloads at unmatched speeds. Thus, the SR-72 Darkstar project was born. The development of such an aircraft would ensure the U.S. maintains air superiority, enabling rapid intelligence gathering and precision strike capabilities in hostile territories. SR-72 Darkstar, breaking barriers with hypersonic technology. Officially announced by Lockheed Martin in 2013, the SR-72 Darkstar is expected to fly at speeds of up to Mach 6 to 4,600 miles per hour, twice the speed of its predecessor. Unlike the SR-71, which relied purely on speed and altitude to avoid threats, the SR-72 is designed with modern hypersonic capabilities. making it an intelligence, surveillance, reconnaissance, and potential strike platform. One of the most groundbreaking aspects of the Darkstar is its engine system, which is designed to transition between subsonic, supersonic, and hypersonic speeds seamlessly. This is achieved through a combined-cycle engine system that integrates a conventional turbofan engine with a dual-mode scramjet engine. The scramjet technology allows the aircraft to maintain hypersonic speeds for extended periods, making it virtually unstoppable. The challenges of hypersonic flight. Developing an aircraft capable of traveling at Mach 6 is no easy feat. The biggest challenge is dealing with extreme heat as an aircraft moves through the atmosphere at such speeds. Air friction generates temperatures that can melt conventional metals. To combat this, the SR-72 is expected to use advanced composite materials and heat-resistant ceramics, allowing it to withstand temperatures above 3,000 degrees Fahrenheit. Another major obstacle is maneuverability and control at hypersonic speeds. Traditional control surfaces become less effective at such velocities, requiring innovative solutions like active cooling systems, advanced flight computers, and cutting-edge aerodynamic designs. From Hollywood to reality, the SR-72 in Top Gun, Maverick. Public interest in the SR-72 skyrocketed in 2022, thanks to its appearance in the blockbuster movie Top Gun, Maverick. While the aircraft seen in the film was fictional, it was heavily based on real concept designs from Lockheed Martin's Skunk Works. This unexpected exposure fueled speculation that the SR-72 was closer to reality than previously thought. Recent developments and future prospects. In 2021, the U.S. Air Force released a promotional video showing what appeared to be a prototype hypersonic aircraft closely resembling the SR-72. This led to increased speculation that flight tests were already underway. Further confirming these rumors, Lockheed Martin revealed in 2023 that the propulsion system for the SR-72 had been successfully tested. According to recent reports, the first test flight of the SR-72 prototype is scheduled for 2025, with full operational deployment expected by 2030. If successful, the SR-72 will not only replace the SR-71 but also serve as a platform for launching hypersonic missiles, providing the U.S. with a game-changing military advantage. The global hypersonic arms race. The development of the SR-72 comes at a time when hypersonic technology is becoming a focal point in global defense strategies. Russia has already introduced the K-847M2 Kinzhal hypersonic missile, while China has tested the DFCDF hypersonic glide vehicle. With the introduction of the SR-72, the United States aims to solidify its dominance in hypersonic warfare. A new era of aerial supremacy. The SR-72 Darkstar represents the future of high-speed reconnaissance and warfare. With unmatched speed, advanced stealth capabilities, and the potential for hypersonic strike missions, it is set to redefine aerial combat for decades to come. While there are still technological and financial hurdles to overcome, the confirmation of its development marks a major milestone in military aviation. As the first test flight of the SR-72 approaches, the world watches in anticipation. Will the Darkstar live up to the legendary status of the SR-71 Blackbird? Only time will tell, but one thing is certain: the era of hypersonic warfare has arrived. That's a wrap on our deep dive into the SR-72 Darkstar, the next-generation hypersonic marvel. If you enjoyed this breakdown of cutting-edge aviation technology, make sure to hit that like button and subscribe to our channel for more mind-blowing content on military aircraft, technology, and defense innovations. Have thoughts on the SR-72? Drop a comment below. We'd love to hear what you think about the future of hypersonic flight.